are based on the metal we use for the casting. The another classification is job-in foundry and repetition foundry. Job-in foundry means we can anyone tell me the job-in foundry? What is job-in foundry? That means which specialize in small orders for wide variety of engineering shapes. මේකට උදාහරණයක් කියන්න පුළුවන්ද කාට?
කෙනෙකුගේ ප්‍රතිමාව
මොකක්ද?
මොකක් හරි ප්‍රතිමාවක් වගේ එකක්.
Oh, we can take that as an example for job-in foundry. And the repetition foundry means if we need some part like think the part of the exhaust manifold of a engine, we need that part again and again. For that, so in that case, we have to go that repetition foundry. Okay, that's for mass production. Okay. Then these are some materials, different materials that can be take for the casting process. The mostly used material is the cast iron. Okay, this shows the density, melting point, and the thermal conductivity. Another important reason, there is an important reason for taking the cast iron as the most casting process. What is this? What's the reason why we take the cast iron mostly? We take this cast iron for casting process mostly because of its fluidity. Fluidity means the ability to flow. The liquid molten metal can easily flow. That's the reason for mostly get this cast iron for foundry works. Okay. Then let's move into the why we used sand as the material for made the mold cavity. අපි මේ sand ගන්නේ mold cavity එක හදන්න. මම සිංහලෙන් පොඩ්ඩක් explain කරන්න. ඇයි අපි sand ගන්නේ mold cavity එක හදන්න? අතන මම කැමති මේක discussion එකක් විදිහට යනවා නම් ඕගොල්ලෝ මට උත්තර දෙනවා නම් මට ලේසි ඕගලන්ට තව ටිකක් explain කරන්න. මොකද මම කියන්නේ දන්නේ නැහැ ඕගොල්ලන්ට කොච්චර අයිඩියා එකක් තියෙනවද කියලා මේක ගැන.
Due to
Yeah,
temperature tolerance.
that's yes. Another. What else? Improve the quantity means ah the main reason is for heat resistant material. Hmm. Let's think about if we take the material
Cost.
as yes low cost. Heat resistant material are
Reusability.
uh, what? I can't hear you. Reason. Resisting material. Then is a heat resisting material. Again, then let's say we use plastic as the uh, material that we use for made the mold cavity. Then what will happen? We use plastic as the material. Then what will happen?
It will liquefy.
Yes, it's also liquefied, and we can't get the shape. But we using the sand. We are using the sand. Sand has the sand is a heat resistant material. Then the shape is not changed. Okay, that's why we use sand as the material. There are another materials we use for that. Mostly use material for made the mold cavity. Okay, uh, I explained this earlier. Why cast iron? Why cast iron? That's due to the fluidity of the cast iron. The fluidity is high in the cast iron. That means කියන්නේ cast iron කියන එක melt කරාට පස්සේ ඒක ගලාගෙන යන්න පුළුවන්. කියන්නේ ගලාගෙන යාම වඩාත් පහසුයි. එතකොට ඒක අපි හදන සිස්ටම් එක ඔස්සේ ලේසියෙන් ගලාගෙන ගිහිල්ලා mold cavity එකේ කියන්නේ ගොඩක් හොඳින් පිරෙනවා. කියන්නේ අර porosity එක අඩු වෙන විදිහට, bubbles අඩු වෙන විදිහට, ඒක ඇතුලේ void spaces අඩු වෙන විදිහට ඒක ඇතුලේ හොඳින් පිරෙන්න හේතුව තමයි fluidity එක කියන්නේ. ඒකට ඒක cast iron වල ගොඩක් වැඩි. ඒක තමයි cast iron අපි ගොඩක් use කරන්නේ casting process වලදී. ඒ ඇත්තට මේක අපිට ඕනි එක අපි ඒකට ගන්න material එක වෙනස් වෙනවා. Okay. Then first we melt the material and pour into the pouring cup. Then it is solidified. Uh, Actually, there is a phase change. No, this shows the liquid phase into solid phase. In solid phase, you can see the grain structures. I think you know about the grain structures. You can search in the internet about the grains structures for your further readings. Okay, then it's solidified. We can get out that uh, casted part. Then we have to break that mold cavity. We break the mold cavity and take out the part. Okay. What is mold? The mold cavity එක එහෙම මම කිව්වට විස්තර කරේ නැහැ මොකක්ද කියලා. ඒක ඉස්සරහට විස්තර කරන්න. හරිද? මොකක්ද මෝල්ඩ් එකක් කියන්නේ? MOLD and MOUL is both are correct. Okay. Actually, there are three parts here. Can anyone tell me what are these three parts? The white color, yellow color, and the other part. What are these three parts?
White one is the testing subject.
Testing means
Before using metal, uh, I think it will use like plaster Paris, like something to mold it.
mm-hmm. These two parts are shape, no?
First one is manufactured item.
Hmm.
Second one is mold, and third one is casted. Casted. Casted sand. Sand casted. Casting.
Mm, any idea? What else? What are the anyone? Actually, the first one is the real part that we need. The second white color one is the pattern. We call this white color one is as the pattern. Uh, Third one is the mold cavity. Actually, we use this yellow color one using the sand. Pattern. What uh, what does it mean by the pattern? This pattern and the part are parts have same shape. මොකද මේ pattern එකක් කියන්නේ? What is the pattern? A pattern may be defined as a model or replica of desired cast into form and impression. ඒ කියන්නේ දැන් අපිට මොකක් හරි හැඩයක් හදා ගන්න ඕන කියලා හිතමු. එතකොට ඒක අපි සෑන්ඩ් එක ඇතුලේ void space එකක් නේද? mold cavity එක කියලා අපි ඒකට කියන්නේ. mold cavity එක හදාගන්න අපිට required shape එකට අනුව ඒක හදාගන්න ඕනේ නේද? එහෙනම් අපි dummy එකක් වගේ එක use කරන එක. ඒක තමයි pattern එක කියන්නේ. එතකොට මේ රූපේ තියෙන මේ සුදු white colored object එක කියන්නේ pattern එක ඇත්තටම. මේ සුදු පාට pattern එක use කළා තමයි අපි මෙන්න මේ කහ පාට රූපේ තියෙන මේ ස්පේස් එක හදාගන්නේ ඇත්තටම. ඉස්සෙල්ලාම මේ හැඩේ හදාගන්න ඕනේ මෙතන. මේක හදාගත්තට පස්සේ මේකට තමයි අපි molten material එක දාලා අපිට අවශ්‍ය කරන හැඩේ හදාගන්නේ. එතකොට අපිට අවශ්‍ය කරන පාර්ට් එකයි ඒක හදන්න යූස් කරපු පැටර්න් එකයි කියන්නේ එකම වගේ ඔබ්ජෙක්ට් දෙකක්. එතකොට අපිට මේ සේම් පැටර්න් එක ඉස්සරහට යූස් කරන්න පුළුවන්. එක පැටර්න් එකක් ඇති මේ හැඩය හදාගෙන මේ ටික ඔක්කොම හදාගන්න. නේද? ඒක තේරෙනවද? Hmm. The pattern is the model. Pattern is another model, the same shape of the final object. Okay. Patterns are modeled for the object be cast. The patterns make an impression on the mold. Liquid metal is poured into the mold and the metal solidified in the same shape of the original pattern. Okay. The pattern and the final shapes are same. Did you get that point? ඒක තේරුණාද? පැටර්න් එකක් කියන්නේ මොකක්ද කියන එක තේරුණාද? You can see this. If you need this black colored part, we made pattern like this. We made this pattern in using the wood because we can easily shape the wood as the pattern. Okay. මේක pattern එක කියන්නේ මොකක්ද කියන එක තේරුණාද? මට confirm කරන්න උත්තරේ තේරුණාද කියන්නේ. Okay.
Yes, I clear.
Okay. Then the pattern making materials. Hmm. The mostly widely used material is the wood. What are the reasons for we using wood? We are using wood. It is cheap and light. Okay. It can be cut and fabricated into numerous forms by gluing, bending and curving. Okay. Because we can easily shape using uh, tools using wood workshop. No, and can create a smooth surface by sanding. And it has tendency to wear by constant contact with sand. Uh, the main reason is the durability and the ability to shape easily. Okay. Wood is the more widely used material in making the pattern. Okay. එහෙනම් අපිට wood එකක් කියන එක carpentry shop එකක තියෙන tools ටික use කරලා ලේසියෙන්ම අපිට ඕන කරන හැඩය හදාගන්න ලේසියි වෙන material එකකට වඩා. ඒත් අපිට ඒක pattern එකක් විදිහට use කරන්න ලේසි. Okay. Then another material is metal. If we need large number of castings, we need that kind of these metal patterns because the pattern can be damaged with the time. So we use metal pattern as the pattern. Okay. So we can use cast iron, brass, aluminium, and alloys for making the patterns. The aluminium we use for the main reason is the lightweight and the high strength. The properties of the aluminum material, when we consider that it is very light material and it has high strength, corrosion resistive, liable to damage easily by accidental contact. These are some metals used for made the pattern. Okay. This is a pattern of an impeller that you made from the metals, and this is a wooden pattern. We can shape this easily shape this part. Okay. then the pattern and the final shapes are same. Then the plaster, you know, the plaster of Paris or gypsum cement. These are another materials. It can be easily casted into intricate shapes and can be easily worked. Has high compressive strength. Actually, the plaster of Paris has a very high compressive strength. Mm, we use this plaster for make the small patterns, small kind of patterns. In small kind of patterns, we use the plaster. Another material is plastic. Thermosetting resin. Resins means, did you heard about the thermosetting resins? Thermosettings, thermosets, thermoset materials. That means once is it create it, its shape not change with the thermal energy. When we supply thermal energy into this shape, the shape of this object is not changed. Those are the thermosetting materials. Thermosetting resins වලට examples මොනවා හරි කියන්න පුළුවන්ද කාට හරි? Thermosettings අපිට පුළුවන් thermosettings setting resins use කරන්න අපේ pattern එක හදාගන්න. අපිට thermosetting material එකකට උදාහරණයක්. Beeswax is another material for wax. Uh, but it's not a thermosetting material.
Silicon.
No. Mhm. Okay. You can you can search these things. Okay. I give you this as a homework. Okay. What are the thermosettings materials? Search about that. Okay. We can use thermosetting materials as to make the pattern. Okay. Actually, it has a heavy, it has a very smooth surface finish. මෙතන මම දැන් මේකට උදාහරණයක් කිව්වොත් ඔයගොල්ලෝ ඒක හොයන්නේ නැහැ. ඒකින්ද thermosetting materials ගැන පොඩ්ඩක් හොයන්නකෝ homework එකක් විදියට. හරිනේ.
Polyamide.
හ්ම්. මොන ආයෙ පොඩ්ඩක් කියන්න බලන්න මොකද්ද?
Polyamide.
හ්ම්. What else?
Polyesters.
Mm-hmm. Okay, you can search that. Yeah. Then pattern making tools. Wooden patterns are basically made by the carpenters. Okay. Usually we use carpentry tools for shape the wood. Okay. The pattern making process, we have to consider this shrinkage scale or contraction scale. Mm, what's the reason for that? Actually, the contraction scale is larger than the normal scale. There is a reason for that. Why? මොකක් වෙන්න පුළුවන්ද මේකට හේතුව? What's the reason for that? අපි pattern එක මේක් කරද්දී ඇත්තට මේක හදන්නේ අපිට required shape එකට වඩා පොඩ්ඩක් වැඩි වෙන විදිහට. What's the reason for that?
For finishing.
Hmm. For finishing. What else?
Finishing is sanding papers and others with it uh, it reduce the size.
Hmm. Did you remember the reason? What's the shrinkage means? What's the meaning of shrinkage? Shrinkage scale and the contraction scale is those are same. Okay. What's the meaning of shrinkage? Hmm? I explained earlier. Shrinkage and porosity. Here, shrinkage and porosity. What's the meaning of the shrinkage? Hmm? Sorry. Shrinkage කියන්නේ අපි phase change එකක් වෙනවනේ. There is a phase change in liquid phase into solid phase. Then what's happened? The volume of the solid body is decreases with the time. Yes. The volume of the this solid body is decreases with decrease in the temperature. නේ? කියන්නේ අපිට solid body එක liquid phase එකකින් ඉඳලා solid phase එකට ඇවිල්ලා එතකොට කොහොමත් එතෙන්දී volume එකේ අඩුවීමක් වෙනවා. දැන් අපි හිතමු එහෙම පරිමාවක් තියෙනවා කියලා. කියන්නේ අපි හිතමු මේක 15යි 15 milliliters liquid මේක solidified වෙද්දී මේක 13කට ඒ වගේ 17කට 12. ඒ කියන්නේ යම්කිසි ප්‍රමාණයකින් අඩු වෙන්න පුළුවන්. තියෙන වොලියුම් එක. මොකද අපි දන්නවා මැටීරියල් එකකට හීට් එක සප්ලයි කරද්දී ඒක ප්‍රසාරණය වෙනවා කියලා. ඒ වගේම හීට් එක අයින් වෙද්දී එතකොට ඒක සංකෝචනය වෙන්න පුළුවන්. ඒකට අවශ්‍ය කරන tolerance එක තමයි මේ තියෙන්නේ. This is the tolerance that need for solidification. Okay. කියන්නේ අපි දැන් අපිට ඇත්තටම required shape එක මේ ඇතුළේ තියෙන shape එක කියලා හිතමු. volume එක. හැබැයි අපි pattern එක හදද්දී ඒක හදන්නේ මේ tolerance එක තියලා. There is a gap between this. Okay. Then it's solidified. We can get the required volume. සහ අර කලින් කිව්වා වගේ මේක post manufacturing operations වලත් මේක වෙනවා. කියන්නේ මේක surface finish එක ගන්න අපිට sand papers use කරලා මේක වටේ sanding කරන්න වෙනවා. එතකොට sanding එතකොට material ටික අයින් වෙනවා. එතකොට ඒවට tolerance එකක් තියන්න ඕනේ. ඒකෙන් තමයි අපි මේ shrinkage scale එක කියන එක මේකට use කරන්නේ. ඇත්තටම shrinkage scale එක කියන එක normal scale එකට වඩා පොඩ්ඩක් වැඩි. ඒ කියන්නේ අපි හිතමු normal scale එකේ සෙන්ටිමීටර් 10ක් කියන එක shrinkage scale එකේ සමහර විට සෙන්ටිමීටර් 11ක් කියලා සලකන්න පුළුවන්. ඒතර අපි මෙන්න මේ වගේ වෙන ස්කේල් එකකින් මේක හදනවා. ඒතර අරක shrinkage effect එකකින් හින්දා අන්තිමේදී finally solidified වුණාට පස්සේ ඒක පොඩි වෙනවනේ. එතකොට අපිට finally ගන්න ඕනේ shape එකට ඒක හදාගන්න පුළුවන්. Did you get that point? ඒක තේරුණාද? Okay. Then let's move into the pattern making. Types of pattern. Section. The selection of the types of pattern depends on the shape and size of the casting, the number of casting required, the method of the molding. And common types of patterns are solid or single pieces pattern, split pattern, match tape pattern. Actually, I'll explain you about this red colored one only, other ones for your further readings. Okay. Solid or single piece pattern. It has a compact single solid body. Okay. Actually, this is a single part. We don't need two separate parts or uh, two parts in the whole system. කියන්නේ අපිට මේ වගේ shape එකක් නම් හදාගන්න තියෙන්නේ අපිට මේක තනි ඔබ්ජෙක්ට් එකක් විදිහට තියන්න පුළුවන්. තනි ඔබ්ජෙක්ට් එකක් විදිහට හදලා මේ කාස්ටිං කරන කියන්නේ සෑන්ඩ් එක යූස් කරලා කරන මේ සිස්ටම් එකේදී මේක කියන්නේ දෙපැත්තක් නෑ ඇත්තටම. මේ තනි ඔබ්ජෙක්ට් එක මෙතන සෑන්ඩ් එකේ ගිල්ලලා මේ required shape එක හදාගත්තා ඊට පස්සේ මේක අයින් කරන්න පුළුවන්. තනි ඔබ්ජෙක්ට් එකක්. ඒතකොට මෙතන ඇත්තටම ටේප් එකක් ඕනේ වෙනවා. tapered shape එකක් තියෙනවා. Can anyone tell me what's the reason for that? Why we need tape shape for that? Hmm. What's happened? It don't have it don't has any the tapered shape. මොකක්ද මේකට හේතුව? මේ තනි ඔබ්ජෙක්ට් එකක් හදාගන්න තියෙන්නේ. එතකොට මේ සෑන්ඩ් බොක්ස් එකේ එක පැත්ත යෝනි අද්ද. මේකේ ගිල්ල පැටර්න් එක හදලා මේක අයින් කරනවා. ඊට පස්සේ මේකට මෙටල් මොල්ටන් මෙටල් එක දාන්න තියෙනවා. පෝ කරන්න. ඒතර අපිට මේ ටේපර්ඩ් ෂේප් එකක් ඕනේ වෙනවා. මෙහෙම තිබ්බේ නැත්නම් මොකද්ද වෙන්නේ? කාට හරි කියන්න පුළුවන්. Can we make this type of object using this solid single piece pattern? This kind of object can be made. පුළුවන් ද අපි මේ වගේ shape එකක් හදාගන්න. මේ object එක මේකේ හදලා ඉතින් බැලු බැලමට ඕගලන්ට මොකද හිතෙන්නේ? මොකද වෙන්නේ දැන් අපි මෙහෙම මේක තියලා මෙතනින් ඔය sand තියෙන box එක හදලා මේක පුරවනවා. sand වලින් පුරවනවා. We fill this box using the sand to make the mold cavity. Then what will happen? Hmm. මෙන්න මෙතන මේ වගේ shape එකක් හදනවා. මෙහෙම එකක්. Can we make this mold cavity? Mold cavity means the space we need. Can we make this shape? Hmm. අපිට පුළුවන් ද මෙහෙම හදලා මේ sand මේ mold cavity එක damage වෙන්නේ නැතුව මේක උඩට ගන්න. Take it out. Can you take? Difficult. අපිට difficult එක ගන්න පුළුවන් ද ඒක? But the, yes, we can't take it out. In this kind of object, we have to go to another method. If you can made this part using the single piece pattern, this part, this dumbbell shape part, yes, we can't. මොකක්ද මේකට හේතුව? දැන් අපි මේක සම්පූර්ණයෙන්ම මෙතනින් ගිල්ලන්න වෙනවනේ. හ්ම්. හ්ම්. මෙහෙම ගිල්ල. We can't take it out. Okay. Split pattern. Then we have to go to the split pattern. Most of the patterns are not made in single pieces. Okay. A pattern consisting of two pieces is called split pattern. Just make two parts and combine these parts. That's called the split pattern. It has drag and the cope. Drag means the lower part of the mold, and the cope is the upper part of the mold. Then we combine the upper part and the lower part. We can make the desired shape. Okay. The upper part, the line of the separation of part is called parting line or the parting surface. The line of the separation of the drag and cope we called as the parting surface or parting line. Also, there are some this called as the multi-piece pattern. That means it has pattern with three parts. We call those parts as multi-piece pattern. The middle part of the modeling box is known as the check. Okay, you will see. two-piece split pattern. You can see how it may. Yeah. This is the upper part. This is the lower part, and this void space is called as the mold cavity, and the middle part is the sand core. Why we need this kind of core? What's the reason of this? ඇයි මේ කෝ එකක් තියන්නලා තියෙන මෙතන? ඔයගොල්ලන්ට ඇත්තටම පුළුවන් වෙන්න ඕනේ මේ වගේ ඉමේජ් එකක් දැක්කහම මෙතනින් මොකක්ද හැදෙන්නේ කියන එක ඉමේජින් කරන්න. එතකොට මේ කෝ එකක් කියන එක තියන්න වෙලා තියන්නේ ඇයි? No. උත්සල ගන්න නෙමෙයි. Any idea? Yes, formate the inside hole. Avoid for spread. Mm. If you need to make this kind of a short tube casting, it has a hole. It has a hole. If you need make a hole in some part, we have to use this kind of core. The core is made by another breakable material because we have to remove the core after the casting. Okay, we have to remove the core after the casting, but we have to make this hole now. Allow for expansion due to formation of cracks. No, the reason is for make hollow parts or inside parts. Okay, two-piece and three-piece split pattern. The much complex structures we have to use three part core, check and the drag. Use the final part using the combination of these three parts. Okay, I'll explain this terminologies in the upcoming slides. And I show you a small video. Okay, can you see the video? Can you see the video?
See, can sir.
called a split pattern. Split pattern means two of comes. One of comes from top box, one of comes from bottom box. The one pattern is the single piece pattern. It's called a single piece pattern or solid pattern. It is the molding box. Here are two top boxes. The top box is called the two box, and the bottom one is called the drag box. Then we want to create the cavity using the pattern. First, we want to use the bottom box. Lift the top box, take it out from the
Okay. What is this? These parts? Can you hear this part? Can you see this part? What we call this parts? What's the name of this part? These two items. These two are the patterns. Okay.
the bottom box is the position of the box. Before this, first we want to remove the box. Just observe it. The slot wants to go from bottom side. When we are using the pattern, the slot wants to go from bottom side. Once the box is positioned, means place the pattern. It is the split pattern. The split pattern is a double pin concept. Where the flat surface is there, that we want to place it properly. Place this one properly in the middle. Now apply the little bit potting fan or chalk powder. Why we are applying this means the fan don't want to stick in floor itself. Apply just like a powder. Now we are using the green sand. The green sand we have clay and red and silica sand moisture. There is a certain percentage only we want to mix the clay and moisture and bentonite powder. Already we have mixed the green sand. Just here it is the sand. And if nothing will happen, so use your hands and we don't want to require gloves up. Why means here we are just moisture and clay and bentonite powder is mixed in the sand. Just arrange the sand. Not we cannot. Next, use the pin hammer. It is called the pin hammer. Why we want to use the pin hammer means the corners properly we want to do the ramming for using the pin hammer itself. Once the ramming is completed, means again put the sand, do the ramming. Use the leveler. It is called the leveler. When you are using the leveler, at a time you cannot level the box. Step by step, you want to do the leveling. The box. Box.
Okay. This is the cope or a deck. This is the upper part or lower part of the box. Okay. Then we have to remove this part, remove this pattern out.
FOT is here. Now pattern is here is there. One more pattern. Properly where the double hole is there. There we want to match the double pin like this. Properly once the pattern is placed means place the once the top of place means here. Now we want to use the screw pincer. It is called the screw pincer. The bigger diameter is called the just for identification, which is the runner. It is the razor. We want to place the runner from away from the pattern. The razor, we can place it from away also in pattern itself also. Place it here.
Okay, students. What is this part? These parts. What's the purpose of these two parts? Hello. Can you hear me? Hello. Am I audible enough? Okay. What is this? What is this? These two parts? What's the need of this? Okay, we will discuss this after the video.
Now take the sand, put it and do the ramming approach. Before putting the sand, apply the little bit potting sand. Same way, how we will ram the bottom box, the same way, step by step, we want to ram the top box. Now, top box also, ramming is now use the level and level the top box also. But when we are leveling the top box, we want to level, while it's the runner and laser. Here also, step by step, now carefully lift the top box. Just observe one impression is the, it is the runner impression. This impression we want to do the marking. By means it is the gate. We want to cut the gate from here for pouring the molten metal. Just mark the impression. Your round impression, the runner impression is there now. Just mark it for that impression. That wants to connect with the pattern. Now make the dip for maximum we can make the 5 mm, minimum 3 mm. Create the gate here. Now we have cutted the gate. Just clean the gate. Just observe how to clean the gate. Finish the corners. This is the gate. Now lift the pattern. Here, holes is there. Using the lifting convention, we want to lift the pattern. Before lifting the pattern, we will close the pattern. Then the pattern becomes easy. Now use the lifting properly, slightly with the pattern. It is called the
Okay, this is called the mold cavity. This part calls the runner. That's for flow in the liquid molten materials. Okay.
cavity. Now look at one more top box. Now this created the cavity. Now we have placed the top box from the bottom box itself, means here itself we are pouring the molten. Just observe now. Just we want to place the top box. It is fully finished. We have created the cavity from split dumbbell shape split pattern. Then we want to place the cavity. We want to do some pouring. Most importantly, we want to know the tool's name. It is called the bone hammer used for the ramming operation. It is used for the pin. It is the knife. We can this way. Just observe how to finish the smoother. Just observe how to smooth the like this. We can smooth the surface. Use the small lip leveler and level this one properly. Don't put it more sand. How much required, that much only want to put. We can finish it like that. Now we are completed to update the top box. Now, before opening the water meter, we want to put some weight. While we pour the water meter, some gases also come out from sand itself. This is called the rainfall.
මොකක්ද දැන් කරන්න කියන එක කාටද කියන්න පුළුවන්? ඇයි මේ අපි සුදුරු හදන්නේ මේකේ?
Now, this way itself, we want to pour the water meter. It is the laser. Whatever the cavity we have created inside, once the cavity is filled with the extra meter comes from the riser itself. That time you want to stop for pouring the molten meter. It is fully completed for up to pouring the now we pour the molten meter. It is not in we are pouring the wax. So the riser is filled with, we want to stop for pouring the molten metal. Now we will pour the molten. After solidification, we want to break it. We want to give a little bit time for solidification. After it is fully solid means we want to break the box, and whatever the cavity we have created inside the casting becomes as it is. Now it is we have poured the molten wax. We want to give the time for solidification. After solidification, we want to let the top box. It is fully solid. Now let the top box. See, we have broken the top box. See how the casting is stable. It is the razor, it is the runner. Finally, we want to cut the razor and get runner out.
Okay, you can see these two parts. This is where we pour the molten material, and this is the riser. We can see the after filling this whole mold cavity in the liquid molten material, it will rise up. Then we guarantee all the volume will filled with the molten material. Okay.
Then the casting will comes. save all the
Finally, we have to remove that uh, excess parts. Then finally, we can get the desired shape. Okay.
you use the split pattern. Two of casting will use one up from bottom box, one up from top box. For the casting will turn single click. See the dumbbells, how the dumbbell shape is prepared from using the wax.
Okay. Uh, did you get that? Hello? Can you hear me? Can you hear me?
Yes, sir.
Okay. Did you get the I get an idea about the split pattern watching this video? Then the match plate pattern. The third pattern type is the match plate pattern. That's a single pattern. No number of patterns may be mounted on a match plate. The plate can made out of the wood or metal, mostly the aluminum. The reason for using the aluminum is the lightweight and the high strength. Okay, because it is durable material. Okay, that's why we use aluminum as the pattern making material. Uh, for most use the then the cope and rag portions of the split patterns are mounted on the opposite side of the plate. You can see this image. Okay. This is the upper part and this is the lower part. The upper part and lower part, both of two are attached with the one single plate. Okay, that means we if we need to make this part, okay, we can cut it in this plane and mounted this upper part to the upper side of the plate and lower part is to lower part of the plate. Then we can make the riser. I'll explain the riser and the other things later. Then we can make this whole part as the pattern. Hmm. Uh, the the main reason for that is that match plate pattern is the high production rate. Can anyone tell me what's the reason for that? What's the reason for that? Why it has a high production rate using this match plate pattern? And it also has a greater dimensional accuracy. Okay. What's the reason for the high production rate when we use in the match plate pattern? Any idea? Why? What's the reason? Okay. I'll show you a video and then you can answer that question. Okay. So can you see the video? Hello. Can you see the video?
Yes, sir, we can see the video.
Okay. Here we started with the drag. Okay. Then we fill the core. These are the risers and other parts. Okay. Pouring cups. Then cut a pouring basin. Actually, he increased the size of the pouring cup here. Actually, this is the match plate. This one is the match plate. This is the mold cavity that we need. The required shape. It has the required shape actually. This is the open riser. You can see the materials comes out from the open riser. Then we can ensure the whole mold cavity will fill with the molten material. Okay. Finally, we broke the mold cavity and we can get the part out. This is actually uh, we need only this part. We need only this part. Only this part. But these are the additional materials. Okay. Uh, Now you can answer the question, previous question I asked. So, what's the reason for high production rate when we use in the match plate pattern? Now, can anyone answer me? Can anyone answer me? What's the reason for high production rate when we doing the casting using the match plate pattern? Can you hear me? Need to follow large process. ඇත්තරම මැච් ප්ලේට් පැටර්න් එක කියන්නේ මොකක්ද කියන එක ඔයාලට තේරුණාද? දැන් අපි two piece split pattern එකකදී මේ upper part එකයි lower part එකයි වෙන වෙනම හදලා ඒ දෙක වෙන වෙනම drag එකේ කෝප් එකේ තියලා mold cavity එක හදා ගන්න ඕනේ. හැබැයි අර වීඩියෝ එකේ අපි දැක්ක විදිහට ඇත්තටම මැච් ප්ලේට් පැටර්න් එකක් කියන්නේ මෙන්න මේ වගේ එකක් නේ. එතකොට මේක බොක්ස් එකකට මවුන්ට් කරාට පස්සේ අපිට මේක ආයේ සමපාත කරන්න අවශ්‍ය නැහැ. මොකද මේක සමපාත වෙලාමයි තියෙන්නේ. මේක හරියටම එක මත එක සමපාත වෙන විදිහට මේක ඇටච් කරලා තියෙන්නේ. ඒතකොට මේක අපි ඔය සෑන්ඩ් කාස්ටින් බොක්ස් එකේ තියලා දැන් කෝප් එකට සෑන්ඩ් එක පුරවනවා. ඊට පස්සේ ඒක අනිත් පැත්ත හරවලා ඩැග් එකට සෑන්ඩ් එක පුරවනවා. ඒතර ওই දෙක හරියටම කැවිටි එක හදාගත්තට පස්සේ මැච් ප්ලේට් පැටර්න් එක කියන එක අයින් කරනවා. එතකොට හරියටම මේ උඩ පාර්ට් එක යට පාර්ට් එක දෙක සමපාත වෙලා හිටිනවා. එතකොට අපිට අමතර කාලයක් ගන්න අවශ්‍ය නැහැ මේක සමපාත කරන්න. සායක ගොඩක් ඇකියුරසි එකකින් වෙනවා. එතකොට ඩිමෙන්ෂනල් ඇකියුරසි එක වැඩි. මොකද මේක සමපාත වෙලා. කියන්නේ අපිට අමුතුවෙන් හිතන්න දෙයක් නැහැ මේක සමපාත කරන්න ඕනේද කියලා. හ්ම්. ඒක තේරෙනවද? Did you get that point? Okay. Hmm. Let's move into the terminologies used in the casting. This is the system. In any, we follow the in any casting process. Actually, these are the things you saw in the videos. This is the basing we pour the molten material into the mold cavity. Okay, we pour the molten material into the pouring basin. This is the basing. We have to make this all the things in the cavity uh, with the cavity. This is the open riser and this is the blind riser. This is for uh, earlier I explained about the shrinkage effect. No, shrinkage effect means the reduction of the volume. That means the mold cavity need excess material to fill with that excess volume. So some additional materials need to fill with this mold cavity. So that excess material including with this blind riser and the open riser. This is the gate. There is a reason for this gate. That means if we pour the molten material into this pouring basin, this is flowing through this runner and fill the whole mold cavity. Mold cavity means this green colored one, green colored volume, and the core is the hole. Can you imagine the final part of this final part that we can get out? We can get out this kind of part. So this is the hole. If we look at this part from the top of this system, we can see and this kind of part. This is the hole. Molten material flowing in this runner and fill the whole mold cavity and rise up. Okay, we can see the access material here and the blind riser. When the okay, some mic is on. Please unmute your okay. Then this the proliferation is happening. The volume is reduced. Then the excess materials comes to this mold cavity and we can get the desired volume. Okay. This blind riser and the open riser take that gives that excess materials. And what's the purpose of this gate? There is some slag with this molten material. The slag is contaminated in this gate valve. That means it contaminated in this point and the clean molten material flowing through this funnel and filled uh, this small cavity slowly. Okay. Then the quality of the final product is good. Core. I think I explained the core about the core earlier. We need core to build the interior parts. Okay. Molding material. Molding material means the metals or alloys, likewise any materials. Flask, cope. Cope means the top half of the pattern. Drag is the bottom part of the above features. And co-print. What's the co-print? Co-print is the region that is added to pattern. Co-mold and is used to locate and support the core within the mold. Can we mold එක mold cavity එක ඇතුලේ අපිට අපිට final product එක ඇතුලේ hollow part එකක් හදා ගන්න ඕන නම් අපිට core එක ගන්න ඕනේ. හැබැයි core එක රඳවන්න විදිහක් තියන්න ඕනේ. The supporters are the core print. අපි core print එක කියන්නේ අර core එක රඳවන්න තියෙන. කියන්නේ support එකක් විදිහට තියාගන්න දේවල් තමයි core print එක කියන්නේ. Mold cavity. Mold cavity means the combination of mold material and core produce a shaped hole. Riser. Riser means an extra void created in the mold to hold mold material. I explained this earlier. And that acts as a reservoir of liquid that can flow into the mold cavity to compensate any shrinkage effect. Okay. This is the core print because we have to hold this core in horizontal position here. In this casting process, we have to hold this core in horizontally. Okay. Because we have to hold this now. Because we have to require any support to hold this horizontally. That's called as the core print. Okay. Then the gating system. Gating system is the network of connecting channels used to deliver the molten metal to the cavity. The mold cavity එක ඇතුළට molten metal එක ගෙනියන්න තියෙන channel එක තමයි gating system එක වෙන්නේ. Vent එකක් කියන්නේ මොකක්ද? Vent එකක් කියන එක ගැන idea එකක් තියෙනවද කාටද? What's the meaning of this vent? Vent means there are some additional gases inside these void spaces. In the casting process, we have to remove that excess gases. So we need some vent holes to remove the gases inside the mold cavity. Hmm, that's why in that video they made some vent holes. Okay. Then the parting line is the separation line of the drag and core. Draft is the tape on the pattern or casting that permits it to be withdrawn from the mold. Okay. Then you can understand the core box, spur, choke, runners. Runners are the horizontal channels, gate, controlled entrance. This is another picture of that. This is the pouring basin. This is where we pour the molten material, and it goes through this and flow in this runner, and then it goes through these gates and filled with this mold cavity. Okay. There is some runner extension. What's the purpose of this runner extension? It's for trap the slag. The slag is contaminated in this runner extensions. Okay. And allows to metal to reduce its velocity. It's better to uh, flow flow this material very slow speed. That's affected to the quality of this product. Okay. And uh, this runner system is reduce the turbulences as the material enter the cavity. That turbulences කියන්නේ මොකක්ද? Turbulence කියන්නේ මොකක්ද flow එකක් turbulence කියන්නේ මොකක්ද? What's the meaning of the turbulence? Turbulence කියන්නේ කැළඹුණු ස්වභාවය. ඒ කියන්නේ අපිට පුළුවන් තරම් මේ flow වෙන material එක මේක ඇතුළට slow speed එකකින් කැළඹුණු ස්වභාවය අඩුව කියන්නේ ගොඩක් අඩු මට්ටමක තියාගෙන මේක ඇතුළට enter වෙන්න පුළුවන් නම් මේකේ හදාගන්න පුළුවන් product එකේ quality එක ගොඩක් වැඩි. මොකද මේක ඇතුළට යද්දී يعني ගොඩක් high end මේක ඇතුළට ගියොත් මේක ඇතුළේ void spaces ඇති වෙන්න පුළුවන්. එතකොට material එකේ strength එක toughness එක වගේ දේවල් අඩු වෙනවා. ඒ කියන්නේ කොච්චර energy එකක් කියන්නේ කොච්චර ශක්තියක් තියනවද කියන එක අඩු වෙනවා. Okay. I explain about the cores. Core means the inside interior parts. Okay. What are the cores? Cores are defined as solid bodies used to form the hollow portions or cavities of the desired shape and size in the casting. Commonly, they are made in sand and separately in the core box. As I told you earlier, that also should be collapsible. Otherwise, we can't make the hollow part in the object, because that core materials are also collapsible. Okay, කියන්නේ දැන් අපි core එකත් මේක හදලා ඉවරනට පස්සේ ඒක breakable material එකකින් හදලා තියෙන. කියන්නේ sand ම තමයි ගොඩක් වෙලාවට ගන්න. මොකද අපි මේ hole එක අයින් කරන්න ඕනේ. Making the core. Making core of core is same as the casting process. That is another casting process. Another cavity making process. Core making is and another mold cavity making process. Okay. Same like the previous one. I'll give you this all the links. You can refer these things. Okay. In the type of course that's based on the orientation of this course. Based on the orientation, there are two types: horizontal course, vertical course. Okay, you can refer these things. Type of course: balanced course, drop course. You can read the slideshow. I'll give you the slideshow. Okay, I'll explain you, and you can uh, refer further details using the internet. Type of course. Course settings. What's the meaning of course settings? Course setting means it has to placed in correct orientation and the correct position in molds. That's called as the core settings. Okay. Core pins I explained earlier. Core pins means the place where we place the core. This is the core pins. We have to place this core in correct orientation. Otherwise, that means the axis of the core and the axis of this object is in same axis. The two axes are uh, in not in incline, then there is a problem because we have to ensure the two axes of this core and the object is as same axis. Okay. These are the core setting techniques. You can read this. What will
Recording
happen
in progress.
in the solidification process? We take this y-axis as the temperature and the x-axis x-axis as the time. With the time, the temperature will decreases, and you can these are in this point there is a phase change into liquid into solid phase. That means this is the falling temperature. That means the melting temperature. No? Then it is decreases to this freezing point. Then the temperature will remain as a constant, and in this point the molten material is completely solidified. We call this point as the latent heat. ගුප්තතාවය කියන්නේ. ඒතන මෙතන ටෙම්පරේචර් එක වෙනස් වෙන එක පේන්නේ නැහැ. මෙතන ලික්විඩ් ෆේස් එකේ ඉඳලා සොලිඩ් ෆේස් එකට එද්දී ලික්විඩ් ෆේස් එකේ ඉඳලා ටෙම්පරේචර් එක අඩු වෙගෙන එනවා. ඊට පස්සේ මේක ෆ්‍රීසිං පොයින්ට් එකට ආවට පස්සේ එයා සොලිඩිෆයිඩ් වෙන්න ගන්නවා. ඒ මොහොතේදී ටෙම්පරේචර් එකේ අඩුවීමක් පේන්නේ නැහැ. මේක මම හිතන්නේ ඕගොල්ලෝ A levels වලදී ඉගෙනගෙන ඇති. ටෙම්පරේචර් එක වෙනස් වෙන්නේ නැතුව ඇවිල්ලා temperature will be remaining constant, and then in this point that part is completely solidified. Then the temperature of this solid part will be decreases with the time. Then we can this comes to this point, we can get this out. Okay. And finally, we can remove the mold removal process. That process is can be divided into two categories. Mold is destroyed in expendable molding during the removal of the casting. Most of the sand casting we called as the expendable molds. And the permanent molds are retained. Thus, require injector system to remove the casting. We can use an injector system and remove this uh, mold and get out the part. Finally, we can do the cleaning, finishing, and inspection process. Okay. The inspection is very important in this casting process. That means the quality checking. We can scan in these things. We can inspect by the hand or some any kind of quality checking process. We can check the defects of the casting process, casting product. Okay, and that's it for today. Uh, if you have any question, you can ask now. I'll give you this presentation, and you can refer this. Don't need to prepare any note, but you can use this presentation and find more details about the foundry shops. I'll conduct the second session of this foundry shop in next week. Okay, do you have any questions? මොනවාරි ප්‍රශ්න තියෙනවද? ඔයාලා නෝට් එකක් හදන්න අවශ්‍ය නැහැ. ඒ කියන්නේ කැමති නම් හදන්නත් පුළුවන්. කොහොමද මේ ප්‍රසන්ටේෂන් එක මම දෙනවා. ඉන්ටර්නෙට් එක යූස් කරලා තව දේවල් හොයන්න පුළුවන්. මොනවාරි ප්‍රශ්න තියෙනවද? ප්‍රශ්න තියෙනවද? Do you have any questions? මේ ඔයගොල්ලෝ උත්තර දෙන්න ටිකක් පරක් වුණාම. අතන මයික් එක අන්මියුට් කරලා උත්තර දෙනවා නම් ඉක්මනට ඔයාලට උත්තර දෙන්න පුළුවන්. තව ප්‍රශ්න තියෙනවද මොනවාරි? Okay, if you have no any questions, I'll wind up the session here. Okay, thank you.